Okay, so in this video, I'm just going to go through the solutions for your exam that you did on paper 1. Now I want you to write out all the correct answers, but make sure you still keep the mistakes that you made. So that the day before your paper 1, you can look at the mistakes that you made and you can compare them to the right answers. And make sure you don't make those mistakes in June. Now for question 1 here, we were told that P is 1, 2, 3, 4, 6, and 12. And that Q are the multiples of 4 that are less than 28. So I would write out the elements of Q. Now, part A asks me to get P intersection Q. Or in other words, the elements of P that are also elements of Q. In this case, the things that are elements of P and elements of Q are just 4 and 12. So my final answer for part A is just that. And for part B, I've been asked for the elements of P that aren't elements of Q. So the things that are elements of P but aren't elements of Q are 1, 2, 3, and 6. So these are my answers for A and B. Now let's look at part C. Okay, so for part C, I'm asked to list all the subsets of P intersection Q. In part A, we worked out P intersection Q is 4, 12. The subsets of P intersection Q are, so one of the subsets of P intersection Q is, if you just rewrite this set, just 4, 12 is a subset of 4, 12. Another subset of P intersection Q is just 4. Another subset is just 12. Now there's no other combinations of 4 and 12 that I can list, so it's just those 3. And then the really important one here is the last one. This is called the null set. So you just put a set of parentheses with nothing in it. There's nothing in this set, and it's referred to as the null set. The null set is a subset of every set. So in any question in the junior cert, if you're asked for your subsets of something, the null set is a subset of every set. So those 4 were your answers to this. They're your 4 subsets. Okay, so for question 2, part A, I'm told that a space probe is going to travel 2.27 by 10 to the power of 8 kilometers, and then a further 7.78 by 10 to the power of 8 kilometers. And I'm asked to find the total distance in the form a by 10 to the power of n. So obviously to get the total distance, I just add the 2 distances together, and you get 1005 million. Or in other words, 1005 and then 6 more zeros. But I need to write this in the form of a by 10 to the power of n, where a is between 1 and 10, and n, the power, is a natural number. So in this case, this is all about the decimals, okay? So you need to consider, where is the decimal place at the moment? At the moment, the decimal place is here. That's 1005 million. And I need to move the decimal place so that my number is between 1 and 10. So like, I can't move the decimal place to there, because if it was there, it'd be 10.05. That's bigger than 10. The only place I can move the decimal place to is here. If I had a decimal place there, it would be 1.005, which is between 1 and 10. So I know that I need to move my decimal place to after the 1. At the moment, it's out here. So I should figure out how many times I need to move it. So I'm going to move the decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And if I move it 9 places, it will be 1.005. 1.005 by 10 to the power of how many times I've moved the decimal place. I moved that decimal place 9 times. So it's 1.005 by 10 to the power of 9. Now, obviously this is a distance, so it needs to be in kilometers. If they're both in kilometers, my answer is in kilometers as well. So let's just make sure I've satisfied all my conditions. I need to write it in the form of a by 10 to the power of n. In other words, a number by 10 to the power of another number. Happy days, I've satisfied that one. I need to write, my number needs to be between 1 and 10. 1.005 is between 1 and 10, so happy days, I've satisfied that. And the power needs to be an element of the natural numbers. Natural numbers are whole positive numbers. 9 in this case, clearly it's a positive whole number, so happy days, I've satisfied that one. My final answer is 1.005 by 10 to the power 9 kilometers. Okay, so for question 2, part B, it told me that a spaceship is capable of traveling at 56,000 kilometers per hour. That's the speed. They told me the distance that it needs to travel is 2.27 by 10 to the power of 8 kilometers. And it's asked me to work out how long to the nearest day will it take for the spaceship to travel to Mars. So the first thing you should do, you should write out exactly what I'm writing out here. The first thing you do is you write out your speed equals whatever your distance equals. And then obviously we're dealing with our distance, speed, time triangle. We're looking for time, so if you cover time, that means time is distance divided by speed. I know the distance is 2.27 by 10 to the power of 8. The speed is 56,000. So if you divide it in, that means it would take 4,053.57 hours to travel to Mars. But the question said, how long would it take to the nearest day? Clearly there's 24 hours in a day, so I need to divide the number of hours by 24. That will tell me how many days it will take. And if you do that to the nearest day, your answer works out as 169 days. Okay, so for question 3, we're talking about the growth of bacterial cells. And we're given the number of bacterial cells every hour for 4 hours. And we need to identify what kind of a pattern it is. Oscar says that it's not linear, that it's not quadratic, and so it must be exponential. We need to verify what Oscar is saying. We need to investigate if he's right or if he's wrong. Now what you need to realize is that there's 5 different values, 10, 30, 90, 270, and 810. Which means there's only 4 first differences. I don't need to fill in all 5 of these. There's 5 numbers, there's only 4 differences. So we can leave the first one blank. The difference between 10 and 30 is plus 20. 10 plus 20 would have given me 30. The difference between 30 and 90 is plus 60. The difference between 90 and 270 is plus 180. And the difference between 270 and 810 is plus 540. So you should realize we start off with 5 numbers, which means there's only 4 first differences. So the first difference here is clearly not common, which means it's not linear. Now there's 4 first differences, which means there's going to be 3 second differences. So I can leave the first 2 of these blank. To get from 20 to 60, I add 40. To get from 60 to 180, I add 120. And to get from 180 to 540, I add 360. Again, the second difference is not common, so I know that it's not quadratic. So that's what you have to fill in your table. And your conclusion should be that there's no first difference, so it's not linear. There's no second difference, so it's not quadratic. Sorry, there's no common first difference, so it's not linear. There's no common second difference, so it's not quadratic. In that case, you're going to agree with Oscar, the sequence is exponential. Remember, you can verify if a sequence is exponential by dividing any term by the previous term. In this case, the common ratio would have been the third term divided by the second term is 90 to over 30, or the fourth one, or 270 divided by 90. In any case, any term divided by the previous term will always give you 3. So this pattern has a common ratio of 3, so I agree with Oscar, it's exponential. Okay, so for question 3 part B, we're given 3 different general formula, one of which describes the pattern in part A. And I now need to choose which one is the correct one and give reasons. So in this case, you should have chosen Gary's attempt. Gary's attempt was that the number of bacteria is equal to 10 times 3 to the power of t, where t is the number of hours. Now, your reasons for this, the first reason should be you sub in values. If I sub in certain points here, they should work. I know that when t equals 0, the number of bacteria is 10. And that when t is equal to 1, the number of bacteria is 30. So if I sub in both of those coordinates into Gary's attempt, if Gary's right, then it should work out. So in this case, let's say I sub in t0 equals 10. That means if I sub in, instead of a t I put in a 0, instead of a b I can put in a 10. So if I sub in that coordinate t0 equals 10, I can say that 10 is equal to 10 times 3 to the power of 0. Remember, one of your rules of powers is that any number to the power of 0 is 1, which means I'm just left with 10 is equal to 10. So happy days, it works for t0 equals 10. So it works for that one, but just because it works for one of the coordinates doesn't necessarily mean it'll work for the next one. So we should try it for 2 different coordinates. So now I'm also going to verify that when t equals 1, the whole thing equals 30. So if I sub that in, instead of a b, I can put in 30, and the right-hand side becomes 10 times 3 to the power of 1. 3 to the power of 1 is 3, multiplied by 10 is clearly 30. So I'm left with 30 equals 30. That one's true as well. So that'll be your first reason why Gary is correct. So that's why you chose Gary's attempt. Your second reason could be why you didn't choose the other two. So one of the other equations there was I was told that b is equal to 3 times 10 to the power of t. So let's investigate if that is true for when t0 equals 10. That means if I sub in a 0, the whole thing should be equal to 10. If I sub it into this one, my number of bacteria is 10, and that's equal to 3 times 10 to the power of 0. Remember, 10 to the power of 0 is 1, so I end up with 10 is equal to 3. That one is clearly not true, so the equation b equals 3 times 10 to the power of t is definitely not correct. Now I should just verify that the other one isn't correct either. The other one was that b is equal to 3t plus 10. So let's investigate the same coordinate again. If I investigate, I'm going to investigate if the coordinate t0 equals 10 will fit. So in this case, instead of a b, I can put in 10, and I'm going to let that equal to 3 times 0 plus 10. If I simplify that out, I'll end up with 10 is equal to 10. So that one is true. So the first coordinate fits into that one. But just because the first coordinate fits in doesn't necessarily mean that that's the right equation. I need to verify it by subbing in 2 coordinates. So let me do it over here now. Supposing I continued that one on over here. So far I've verified that one of the coordinates is correct. I now want to verify if another one is. So let's now take t1 is equal to 30. If I sub that one into my equation, b equals 3t plus 10. Instead of a b, I can put in 30, and that'll be equal to 3 times 1 plus 10. Now 3 times 1 is clearly just 3. So the right hand side becomes 3 plus 10, which is 13. Now 30 is not equal to 13, so that one is not true. So we verified that those two are wrong, and that Gary's attempt is correct. Okay, so let's talk now about question 4. This is a really, really important question. A lot of students, I think, wasted a lot of time on this in the exam. If you get stuck in a question and you just can't figure out, you're better off to come back to it with fresh eyes at the end of the test. So I would have left this one be if you didn't get it first time, move on and then come back. In this case, I'm told I'm dealing with people who like horror films, action films, and comedy films. I'm told that X people liked all of them. I'm told that 8 people liked comedy and action films. So that means that these two sections have to add up to 8, which means if I know there's an X in there, this is 8 minus X. I'm told that 6 of them liked horror and action, so if there's an X there, this must be 6 minus X. 4 of them liked comedy and horror. If there's an X there, this must be 4 minus X. I'm told that 9 of them didn't like any of those types of films. Now the things the students struggled with, I think, were getting these 3 sections. So let me just drag these ones out. I'm told that 29 people in total liked comedy films. So in order to figure out what goes here, it would be 29 minus the 3 sections that are already filled. You are better off to write this as a sum and work it out. Now I'm going to actually do it in my box here. You should obviously do it to the side of your box. I'm just running out of space. So in order to work out what goes here, it would be the 29 people in total like comedy films. And I'm going to subtract the 3 sections that are already filled. So it's 29 minus 4 minus X. And I need to put that in brackets because my signs are going to change. So 29 minus that one. Now I'm going to subtract X. And now I'm going to subtract the third one, which is 8 minus X. So in other words, if I just get, right, the whole circle adds up to 29. So if I just subtract, this section will be 29 minus those 3 sections will give me the last section. If you simplify this down, let's just see what happens with our signs here. I get 29, minus by 4 gives me minus 4, minus by minus gives me plus X. And then a minus X, minus by 8 gives me minus 8, minus by minus X gives me plus X. And if I simplify that fully, I'm going to get 29 minus 4 minus 8. In other words, that's 29 minus 12, which gives me 17. But something strange happens with your x's here. You have a plus x and a minus x, so obviously they're going to cancel each other out. And then you're left with a plus x. So it's actually a plus x that goes there. 29 minus those 3 sections will end up being 17 plus x. So that's how many people only liked comedy films. A lot of people ended up with a minus x there, so you're better off to drag that one out. Now, So that's how you'd work that one out. I'm going to wipe it out because technically it shouldn't be in my Venn diagram. If you didn't get the other two sections correct, I want you to try them now. Basically, you'll do the exact same thing. I know that 40 people liked the action films, which means it's 40 minus that, minus that, minus that. And if you work that one out the same way as I worked out my 17 plus x, this one should work out as 26 plus x. I know that 38 people liked horror films, and I've already got 3 sections filled, so 38 minus that, minus that, minus that, you should have ended up with 28 plus x. Now, so the first set of marks are going for that. It said represent the information on the Venn diagram, happy days, that's it represented. I probably don't need that 38, that 40, or that 29. But now, once I have it like that, that's the information represented as much as possible. And for the second part of the question, we're asked to find the value of x. And I know that there's 100 people in total, 100 people in total in this group. Which means that if I add up all of these little sections, let them equal to 100, I'll be able to find the value of x. Okay, so if you've got part A correct, part B is relatively straightforward. I've just taken each section from my Venn diagram and I'm adding them all together, and I know when I add them all together they have to add up to 100. So now if you look at this line, I've got one equation, one unknown, which means I can find the value of x. So the first thing I'm going to do on the left hand side is just group my like terms. If I add up all of the numbers on the left hand side, I get 98. Now in terms of the x's, I have a plus x and a minus x will cancel each other out. This plus x and this minus x cancel out. This plus x, this minus x cancel out, and all I'm left with is 1x. So the left hand side simplifies down to 98 plus x, and I know that that is equal to 100. So clearly to get x on its own, I just need to subtract 98 from both sides. And I just get x is 100 minus 98, so my final answer there is just that x is equal to 2. Okay, so for the last part of this question, we're asked to work out, we're saying if you choose a student at random, what's the probability that they only liked one type of film? So I know the people who only liked horror was 28 plus x, that only liked action was 26 plus x, and only liked comedy was 17 plus x. But in part B, we've worked out that x is equal to 2, which means it's actually 30, 28, and 19. So I just need to find the probability that if I picked a student at random, I would pick one of these people. So it's 30 plus 28 plus 19 divided by the total number of students, which is 100. That works out as 77 over 100, and it doesn't simplify any more than that, so my final answer there is 77 over 100. For question 5 part A, we're asked to explain why minus 7.6 is not a natural number. Well, the two reasons are it's not a whole number and it's not a positive number. Okay, so for question 5 part B, we need to assign numbers to either natural, integers, rational, or real. So let's just start working our way through this. The first one here is the square root of 3. So the square root of 3, well, first thing you would do is if you plug this into your calculator, the square root of 3, it gives you, it's 1 point something something something, but it just goes on forever. It's just random numbers that go on forever. If you plug it into your calculator and it's just different numbers that appear to be going on forever, then that means that it's irrational. It's an irrational number. Basically, if it just continues on forever but it doesn't repeat itself, then it's an irrational number, which means that it's not an element of Q. Remember, Q represents the rational numbers, so it has to be outside the circle for Q. It must be out here. The square root of 3, it's still a real number, but because it's 1 point something 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 that tends to just go on forever, that means that it is not rational. It must be irrational, so it goes out here. The next number I'm looking at is minus 6. Minus 6 is clearly a negative whole number, which means that it's an integer. Which means that minus 6, I'm going to slot that one in Z. So I'm happy out with that one because it's an integer. The next one is 22 over 7. Well, clearly it's not a natural number because it's not a whole number. It's not an integer because it's not a whole number. It's rational because it can be written as a fraction. Remember, your definition for the rational numbers is anything that can be written as a fraction. So 22 over 7, happy days, that's a rational number. Okay? The next one I'm looking at is the number 4. Clearly it's a whole positive number, so it's a natural number, so it goes in there. The next one we have then is 3 to the power of minus 2. If you plug 3 to the power of minus 2 into your calculator, you'll get 1/9. if you use your rules of powers, according to one of your rules of powers, 3 to the power minus 2 is the same as 1 over 3 to the power of plus 2. So you bring your power underneath and it becomes positive. So that's the same as 3 to the power 2 is 9. So that's just 1/9. Again, here I'm dealing with something, it's clearly not natural or an integer because it's not a whole number, but it can be written as a fraction, so that means it's rational. You can't write it in as 1/9, you have to write it as 3 to the power minus 2. Now the next one I'm looking at is 4 root 5. Again, this is the same as the one that we had for root 3. If you plug 4 root 5 into your calculator, it can't be written as a fraction. It's going to give you decimals that keep on changing and that go on forever. So 4 root 5 is irrational. It cannot be written as a fraction. So it must be out here. It's still an element of the real numbers, but it's not rational, so it's irrational. And my last one then is 2/3. To plug in 2/3, straight away, well, it's a fraction. It's not an integer, it's not a natural number, but it is a fraction, so that means it's rational. So your final answer for that, it should have looked something like this. Okay, so the final part of this question, it says it wants you to simplify 3 plus 2 root 5 times 4 minus 3 root 5 without using your calculator and leave your answer in the form a plus b root c. Now if it says without using your calculator, then it means don't use your calculator or you'll get no marks. So this is, you have 2 brackets, you're just multiplying out 2 brackets. You've done this 100 times. It's just you take the first thing in the first bracket, you multiply it by the second bracket. Second thing in the first bracket by the second bracket. So if we do that, it looks like this. 3 multiplied by 4 is 12. Now if you're multiplying 3 by minus 3 root 5, the 3 multiplies by the 3, but you can't do anything with the cert. So basically it's just 3 by 3, that gives me minus 9, and then you've got a root 5. So I didn't do anything with the cert, I just multiplied the 3 by the 3. For the next one I have 2 root 5 times 4. So in this case 2 multiplied by 4 is 8 root 5. Again, I didn't do anything with the cert, I just multiplied the 2 by the 4. For this one, I can multiply the 2 root 5 by minus 3 root 5. You can multiply the 2 by the minus 3, the root 5 by the root 5. 2 multiplied by minus 3 gives you minus 6. Root 5 multiplied by root 5, you could write that as the square root of 25, but in fact it's easier, it's just root 5 by root 5, the surds cancel and you're just left with 5. So that actually becomes minus 6 times 5. Now the question asked me to leave my answer in the form of a plus b root c, which means I just need to simplify this a bit further. My first term and my last term are numbers, and these two terms are like terms. So I'm going to group the first one and the last one and the 2 in the middle. This will become 12. Minus 6 by 5 is minus 30, and then I have minus 9 root 5 plus 8 root 5. 12 minus 30 is minus 18. Minus 9 plus 8 gives me minus 1 root 5. So my final answer there is just minus 18 minus 1 root 5. Okay, question 6 was relatively straightforward. You're given 14 minus 2 times 3x minus 3 equals 44. And it says solve the equation. Solve means find the value of x. So the first thing you do obviously is just your brackets. You multiply minus 2 by 3x, you get minus 6x. Minus 2 by minus 3, you get plus 6. Now on the left hand side, all I did there was I grouped 14 plus 6 gives me 20. Of 20 minus 6x equals 44. You bring your 20 to the other side, it becomes a negative. So minus 6x will be equal to 44 minus 20. So minus 6x is equal to 24. You divide both sides by minus 6 and you end up with x is equal to minus 4. That's your final answer for that bit. Okay, in question 7, we're told that a company buys a computer for €5,904, but that price is inclusive of VAT at 23%, which means that the €5,904 represents 100% of the cost of the computer plus 23% VAT. In other words, it's 123% of the original cost of the computer. And we're told that the company is allowed to claim back their VAT. So we're asked to work out how much money can they claim back. In other words, we need to work out how much of this is VAT. So I would originally say that the price plus the VAT is equal to 123%. Then divide both sides by 123. Because if you divide 123% by 123, you get 1% of the original cost of the computer. If you divide this by 123, you get €48. That will allow you now, I'm doing this a bit long-winded, but that would actually allow you, if you're just looking for 23% VAT. So if you just multiply both sides by 23, you would get your final answer here. I'm doing it slightly differently. I'm trying to find the cost of the computer originally, excluding VAT. So if 1% of the computer is €48, 100% of the computer is 4,800. I just multiplied both sides by 100. So I know the computer actually cost 4,800, but the company had to pay €5,904. So if I subtract the cost of the computer from the cost plus the VAT, I'm just left with the VAT. The VAT on that computer was €1,104. Okay, for question 7 part B, I'm between two minds in which way to show you this one. There's a number of different ways of doing this. There is a formula for it, but I think you're probably safer to just work your way through this question. In this question, we're told that the company is allowed to depreciate the full cost of the computer by 25% every year for 2 years. We need to work out what is the value of the computer what will the value of the computer be in 2 years. So it started off, the full cost was €5,904. In the first year, it's going to lose 25% of its value. If it loses 25% of its value, that means that it will only be, whatever it is now, it loses 25%, so in a year's time, it will only be worth 75% of what it's worth now. So if I can just get 75% of its value today, that will tell me how much it's worth in a year. 75% of this, if I go 5,904 multiplied by 75%, I get 4,428. So that is the value of the computer after 1 year. The value after 1 year. Okay, so after 1 year, it's worth 4,428. Now it's going to lose 25% of its value again. So if it loses 25% of its value again, that means I'm going to multiply this by 75% again. In a year's time, this will be worth 75% of what it's worth now. So if I multiply by 75% again, that tells me that in a year, it will be worth €3,321. So that's your final answer. That's the value after 2 years. And there's a formula for it in your log tables, but it's probably easier for you to use that. Now, I just want you to be aware, another way you could have done that is if it's losing 25% value every year, you could have gotten 25% of the original cost and then subtracted it, and you would have gotten 4,428. Then you could have gotten 25% of that, subtracted it from the value, and you would have ended up with 3,321. Okay, in part C, we're told that the company has had a computer for 2 years and that it has depreciated by 25% each year and that it is now worth €2,250. And I need to figure out how much was it worth 2 years ago. How much was it worth the day that they bought it? So first of all, I want you to consider the 2250, the computer I have today. 1 year ago, in the last year, it's lost 25% of its value. If it has lost 25% of its value, the 2250 is 75% of what it was worth 1 year ago, because it's lost a quarter of its value. So I could say the 2250 is equal to 75%. And I want to work out how much was it worth 1 year ago. 1 year, in order to work out what it was worth 1 year ago, I need to work out what was 100%. So if I say that 75% is equal to this, in order to, the first thing I should do is get 1%. In order to go from 75% to 1%, you must be dividing by 75. You divide the right hand side by 75, you also divide the left hand side by 75. 2,250 divided by 75 gives me €30. So 1% of what the computer was worth 1 year ago is €30. If I multiply that by 100, I go from 1% to 100%. You multiply by 100, that means that 1 year ago the computer was worth €3,000. So today is the computer's 2 years old, and when it was 1 year old, it was worth €3,000. But I don't want to know how much it was worth when it was 1 year old. I want to know how much it was worth when I bought it. So now I need to do the whole thing again. This €3,000 represents, so I bought it one day, and a year later it lost 25% of its value and it was worth €3,000. So if I now want to find out how much it was worth the day I bought it, I now need to consider that the value of the computer after 1 year was €3,000. The value of the computer after 1 year is €3,000, so I just need to do all of this again. I know that now I want to find how much was it worth the day I bought it. So I could say that €3,000 is equal to 75% of how much it was worth the day that I bought it. So if I know 75%, I can get 1% and then I can get 100%. So if I get 75%, I want to go to 1%, so I'm going to divide both sides by 75. If you divide the right hand side by 75, you get 1. If you divide the left hand side by 75, you get 40. I don't want 1% of the original value, I want 100% of the original value, so I multiply both sides by 100. That means that the computer must have been worth €4,000 originally. The original cost of the computer was €4,000. Then it lost 25% of its value and it was worth €3,000. Then it lost 25% of its value again and it was worth €2,250. Okay, so for question 8, we're asked to factorize a number of different things. The first one here, I've got 4 different terms. Now there's a couple of different ways of doing this one, so if you did it differently to me, that's fine, as long as you get the same answer. So what I've done is I've taken the first 2 terms and factorized out what's common. What's common to the first 2 terms is n. If I take out n out of 5n, I'm left with 5, and n out of this, I'm left with minus 2a. So I've got n times 5 minus 2a. If I multiply that out, I'd end up back where I started. Now I need to take what's common to both of these. So what's common to both of these is m. But if I just take an m out of that term, I'll be left with a minus 5. I need it to be a plus 5. I need it to be the same as this one. So that means I know I need to factorize out minus m out of that term. If I factorize out minus m, I'm left with plus 5. Minus m into that term gives me minus 2a. If you're not 100% sure on your signs, you just multiply it out and make sure it's the same. So minus m by 5 gives me minus 5m. Minus m by minus 2a gives me plus 2am. So that means I haven't cheated with my signs, it makes sense. Because I have the same thing in both brackets, I know that I'm on the right track. Your final answer you have to write, you take the 2 things that are outside the bracket, n minus m, and you write that as one bracket, and then the other bracket is 5 minus 2a. So your final answer there is just that. The second one was the difference of 2 squares. You could view that as 6p to be squared, you could view that as 7q to be squared. The factors are 6p minus 7q times 6p plus 7q. And that's your final answer for that one. For question 8 part B, I just need to simplify these fractions. In order to add or subtract fractions, we always get a common denominator. So the common denominator in this case is just x minus 2 multiplied by 3x minus 5. You just multiply out the bottom of your fractions and that's your common denominator. Now you have to ask yourself, how many times does x minus 2 divide into the common denominator? Well, x minus 2 will cancel with itself and it divides in 3x minus 5 times. Which means that it's whatever was above the x minus 2 multiplied by 3x minus 5. And then I take down the minus 2 and I ask myself, how many times does 3x minus 5 divide into my common denominator? 3x minus 5 divides into this x minus 2 times, which means it's minus 2 times x minus 2. Now you don't have to simplify the bottom of your fraction. Notice even at my answer, I've never touched, I just leave the denominator as it is. But I need to multiply at the top. 5 by 3x is 15x, 5 by minus 5 is minus 25, minus 2 by x is minus 2x, minus 2 by minus 2 is plus 4. Now I just need to group my x's and group my numbers. 15x minus 2x is 13x, minus 25 plus 4 is minus 21. So that's my final answer there. Okay, for the final part of question 8, I just need to do long division. Remember, there's 4 separate steps in your long division. The first thing you want to do is divide. You want to divide the first thing here into the first thing here. X into x cubed goes x squared times. Then you want to multiply. You're going to multiply x squared by both of those. X squared by x is x cubed. X squared by minus 2 is minus 2x squared. Your third thing is you're going to subtract. And in order to subtract, you're going to change your signs. So that becomes a minus, that becomes a plus. X cubed minus x cubed is 0. 3x squared plus 2x squared is 5x squared. Your fourth step is you're going to take down the next term. In this case, my next term is minus 4x. And now we're just going to start our process all over again. The first thing we do is divide. We divide the first thing here into the first thing here. X into 5x squared goes 5x times. Now you're going to multiply. You're going to multiply 5x by both of these. 5x by x is 5x squared. 5x by minus 2 is minus 10x. Now I'm going to draw a line underneath and I'm going to subtract. And in order to subtract, you change your signs to a minus and to a plus. So I have plus 5x squared minus 5x squared, which is 0. I have minus 4x plus 10x, which is plus 6x. Then I take down the next term, which is minus 12. And now I start my process all over again at divide. Divide x into 6x, it goes plus 6 times. Now I'm going to multiply 6 by both of those. 6 by x is 6x. 6 by minus 2 is minus 12. Now I'm going to subtract, which means I have to change my signs to a minus and to a plus. 6x minus 6x is 0. Minus 12 plus 12 is 0. So I've divided that into that, and my remainder is 0, so I know that I'm on the right track. Your final answer is x squared plus 5x plus 6. Okay, so for question 9, we're just matching graphs to statements. And the statements refer to the population of 4 different African countries. So the first one was that the population increases steadily. And for that one, you're looking for a line, just a positive slope. Just one that increases, it's linear, but it has a positive slope. That was number 3. The second one I'm looking for is the population increases steadily at first, but then more quickly. That one I'm looking for, it starts off probably the same as this one did, but then it gets steeper, so it starts to go upwards. It's basically gets a steeper slope. And in that case, I was looking for number 1. The third one is the population declines steadily, and that one I'm just looking for a negative slope. And that's number 2. And then the last one was that the population increased quickly at first, but then more slowly. So that one, it's quite steep first, but then it kind of levels off, and that's number 4. Okay, so for question 10, I'm given an inequality and I'm asked to solve it. I'm told that minus 5 is less than or equal to x over 3 minus 4, which is less than minus 2, and x is an element of OR. So what you should do in a question like this is split your page in two. So what I've done on the left-hand side is I've taken the middle bit and the bit on the left. So the middle bit greater than or equal to minus 5. And then on the other side, I've taken the middle bit and the bit on the right, which is the middle bit is less than minus 2. So you just work each one out individually. First of all, you should realize that on this line, my immediate complication is the fraction. And in order to get rid of the fraction, I'm going to multiply everything by minus 3. Minus 5 by minus 3 is minus 15. X over 3 by 3 is x. Minus 4 by 3 is minus 12. Now I just have a simple equation. I just need to get x on its own. So you bring the 12 to the other side, or you add 12 to both sides, and you end up with x is greater than or equal to minus 3. So that's your first bit done. Now you need to worry about the other side. On the other side of all of this is less than minus 2. Again, my immediate complication is the fact that there's a fraction. In order to get rid of that fraction, you're going to multiply by 3. If I multiply everything by 3, I get x minus 12 is less than minus 6. Bring the 12 across, or add 12 to both sides, and I end up with x is less than minus 6 plus 12, which means x is less than 6. So you should say, right, I know that x is greater than or equal to minus 3 and it's less than 6, so that means x is within that range. It has to be greater than or equal to minus 3 and it has to be less than 6. Now, part B, I need to graph this on a number line. So I need to refer to the fact that they said that x is an element of OR. If x is an element of OR, it's an element of the real numbers. Everything you come across at Junior Cert is real. Fractions, decimals, square roots, the whole lot. Which means I want to include everything from 6 to minus 3. So I just put a circle around my 6 and my minus 3. It could be equal to minus 3, which means I shade in this circle. It can't be equal to 6, so I don't shade that one in. And I need to include every single number between minus 3 and between 6. And in order to do that, I'm just going to basically shade in the number line from minus 3 to 6. So for part B, that's what the marks are going for. Okay, the last part of question 10, I'm asked to write an inequality. The inequality, it tells me that the number of people who attended provincial GAA championship finals in 2013 was between 21,274 and 54,485. To represent that as an inequality, you just have to say that x, where x is the attendance at provincial finals in the GAA championship in 2013, it had to be greater than that and less than that. It's not greater than or equal to or less than or equal to, because it said it's between those two figures. It's not inclusive, so it implied that it couldn't be equal to either of those. It was between that and that. So x has to be between them, which means it can't be equal to it. You have to refer to the fact, x is equal to that, you have to state that, but you also need to refer to the fact that x is an element of n. Clearly x has to be a natural number. If x refers to the number of people, it has to be a whole positive number. For example, I can't say that I had 100.6 people at a match. I can't have a decimal, I can't have a fraction, I can't have a negative number. So it has to be an element of your natural numbers. That's all you have to write for your marks for that question. Okay, for question 11, you had to come up with a simultaneous equation. Because I've written down some of the important information here. You've €320 made up of €50 and €10 notes. You've 12 notes in total. That first statement is going to allow me to come up with one equation. The second statement is going to allow me to come up with another equation. They've told you that x is the number of €50 notes and that y is the number of €10 notes. So x is the number of €50 notes, y is the number of €10 notes, and there's 12 notes in total, which means that you can, if you just refer to the number of notes, the number of €50 notes plus the number of €10 notes has to add up to the total number of notes, which is 12. So your first equation is just x plus y equals 12. Now, so you get your first set of marks for that. The second set of marks, now the second equation, we have to think about the value of the money. If you had two €50 notes, they would be worth €100 in total. In order to work that out, I just multiply 50 by the number of notes. If I have two of them, 50 by 2 gives me 100. If I have four of them, 50 by x, 50 by 4 gives me 200. So you need to realize is that 50 multiplied by x, where x is the number of €50 notes, that tells me the value of my €50 notes. It's 50 multiplied by x. The value of my €10 notes is 10 multiplied by y. So if I add up the value of my €50 notes plus the value of my €10 notes, that will add up to the total value of the money, which is €320. So that's your second equation. And now the next part of the question, we need to solve this equation to find the value of x and y. Okay, so for question 11, I have two equations, two unknowns, so it's clearly a simultaneous equation. So I've lined them up, x's under x's, y's under y's, and numbers under numbers. I'm going to try and get rid of my y's here, which means I've decided to multiply the bottom line by minus 10. If you multiply the bottom line by minus 10, it becomes minus 10x minus 10y equals minus 120. If I now add these together, 50x minus 10x is 40x, plus 10 minus 10 is 0, so my y's cancel. 320 minus 120 gives me 200, so I know 40x is equal to 200. If I divide both sides by 40, I get x is equal to 5. So that's my first value. Then I sub that x value into one of my original equations to find the corresponding y value. So I've decided to use the x plus y equals 12, except instead of an x, I've subbed in a 5. And if I manipulate this down, I get y equals 7. So he must have had 5 €50 notes and 7 €10 notes. And that's your final answer for that part. So, right, 50x plus 10y equals 320 is a line. And x plus y equals 12 is a line. You've just done a simultaneous equation to find the value of x and y. If you've done a simultaneous equation for two lines, you've found the point of intersection of the two lines. And my answer to this simultaneous equation was 5, 7. So basically this question says to draw a graph of each line and verify the answer to part B. Basically what they're asking you to do is draw each line and verify that the point of intersection of the two lines is 5, 7. So now you need to think, right, well, first of all, I need to draw the line 50x plus 10y equals 320. In order to draw a line, you need two coordinates. So you need to find two coordinates on this line. It really doesn't matter which coordinates you find. Obviously, as long as they fit onto your graph, it doesn't matter which ones you find. So I've decided, right, the first thing I was going to do is find the y value when x is equal to 0. So you sub in x equals 0, and if you manipulate it down, you end up with y is equal to 32. So I know that the coordinate 0, 32 is on the line. That's 1 point, but now I need to get a second point. Again, it doesn't really matter what you sub in here. I've decided to sub in 6. If I sub in, I'm subbing into the line. Instead of an x, I'm subbing in a 6. And if I manipulate it down, I end up with y is equal to 2. So I know a second point on the line is the coordinate 6, 2. So now I'm happy out with this line because I have two different points that are on that line. So when I get to my graph, I just plot those two coordinates, join them up, and that's my line. Now I need to find 2 points on the other line so that I can draw that one as well. Okay, so now I'm trying to find 2 coordinates on the line x plus y equals 12. Remember, I want 2 coordinates because that will allow me to draw my line. So I started off by subbing in x equals 0. If you sub in x equals 0, you end up with y equals 12. So one of my coordinates is the coordinate 0, 12. Now I decided to sub in x equals 6. Again, it doesn't matter. You could have subbed in x equals 10 or x equals 5 or whatever you want. But now I'm going to sub in x equals 6 and I end up with y is equal to 6. So now I have 2 coordinates on that line as well. So I have 2 coordinates on each of the lines. Now I'm going to go to my graph, draw the 2 lines, and hopefully they intersect at 5, 7. Now obviously my graph is very rough here. Yours will be much better when you've got lines. But basically what you should do, right, the black line here is my 50x plus 10y equals 320. I plot the coordinates 0, 32, I plot the coordinates 6, 2, and I label them. And you make sure you label your line as well, that's that line. Then for the other line, the one in blue, is x plus y equals 12. You plot the coordinates 0, 12, you plot the coordinates 6, 6, you have your 2 different points, and you draw your line. You should make sure you label your 2 different lines. And then what we were asked to verify is that the point of intersection is 5, 7. So if your graph is accurate, that should be the coordinate 5, 7. If it is the coordinate 5, 7, you tick it and you verify it. If you ended up with something different, try and plot your graphs again. Okay, so all we were looking for there was that they intersect at 5, 7. Okay, so for question 12, part A, we're told that a Gaelic football player kicks a football. We're asked and we're told that the flight of the football can be described as y equals 5x minus x squared. And you should realize that because it's an x squared, it's a quadratic equation. If there's a minus in front of the x squared, you know it's that shape, it's an n shape. Obviously that makes sense. If I kick the football, it'll go up into the air and it'll fall back down and hit the ground. The question says to come up with a suitable domain and draw a graph of the flight of the football. Now, the suitable domain, that means they're your x values. Basically it means you need to know what kind of x values you're looking for and find the corresponding y values. Now, you have to be very careful here. Obviously, you cannot have a negative x value. X refers to the time since the ball was kicked. So you can't refer to 3 seconds minus 3 seconds. You can't have negative time. So definitely your x values have to be greater than 0. You'll lose marks if you start talking about before the ball was kicked. So let's just imagine, let's do a rough diagram of it at the moment. The ball is going to be kicked when t equals 0 or x equals 0. It's going to go up and then it's going to come back down. But obviously, if you just keep getting coordinates, you're going to go below the x-axis. You don't want those points. Obviously, if you kick a football, when it hits the ground, it's going to bounce back up, which means the suitable domain they're referring to is you need to go from when the ball is kicked until the ball lands. So obviously when you look at the question, you won't know what that is straight away, but that's what you should be looking at. You should know that the suitable domain they're referring to goes from x equals 0 up until whatever this number ends up being. So now I hope everyone's able to do this accurately on the calculator. Remember, on your calculator, you can just sub that into your calculator and choose a domain. I suppose in an exam, you'd probably choose a domain. You'd start at 0 and you'd end at, I don't know, 10, or you'd end really far because you don't know how far you have to go in this case. But when you get your coordinates on your calculator, your coordinates end up as 0, 0, 1, 4, 2, 6, 3, 6, 4, 4, and 5, 0. So what that means is that after 2 seconds, the ball is 6 meters in the air. After 4 seconds, the ball is 4 meters in the air. After 5 seconds, the ball has touched the ground again, which means now I know my suitable domain is between 0 and 5, and that's what I actually need to do. So if you're using it on your calculator, make sure you write out your coordinates. You'll get no marks whatsoever if you haven't written out your coordinates. So you can work them out. You could sub in 0, you could sub in 1, 2, 3, 4, and 5, or you can just plug it into your calculator. But either way, you make sure you write out all your coordinates at the end. Once I have them now, I can just plot my graph accurately. Okay, so if I just plot my points now, I plot 0, 0, 1, 4, 2, 6, 3, 6, 4, 4, and 5, 0. The one thing I'd be looking for here, the one thing the marking scheme will be looking for is you have to make sure that you cannot draw a straight line from there to there. If the ball is 6 meters high after 2 seconds and 6 meters high after 3 seconds, then it must have actually gone higher than 6 meters after, say, halfway between those. At 2.5 seconds, it must have been higher than 6 meters. So your graph will have to go a little bit higher than 6. Okay, so that's what I'd be looking for there. Now, so the marks are going for that for just, you write out your coordinates and you plot your graph. Part B now says, how long does it take for the ball to hit the ground? Obviously, for the ball to hit the ground, you're just referring to how long will it take before it reaches the ground again. It's kicked here and it lands 5 seconds later. So the answer to part B is it takes 5 seconds for the ball to reach the ground again. Then the next part of the question, it asks you to estimate the height of the maximum height of the football. So for the next part, you need to estimate the maximum height of the football. The key here is that you cannot say that it's 6. It clearly went above 6 at some point. So there would probably be a range here where they'll accept a specific range. My advice to you is you always go up 1/4 of a unit. So say if it's 6 there and it's 6 there, if I went across here from the maximum height, it'd be a bit higher than 6. I'd estimate that as 6.25 meters. So roughly the height of the ball, the maximum height of the ball was 6.25 meters after 2.5 seconds. For question 12, part D, it's told you that a different football is kicked and the function is y equals ax minus x squared. And they've given you a slightly different graph to the one that you had. They've asked you to use this graph to find the value of a. So you should look back at what we've done previously. When y was equal to 5x minus x squared, the graph went up and down and it intersected, and it took 5 seconds basically to hit the ground again. It took 5 seconds to hit the ground again, and the number in front of x was a 5. This one takes, if you look at that, takes 4.5 seconds to hit the ground, which means that this number is going to be 4.5. That one took 5 seconds to hit the ground, so the number in front of x was 5. This one takes 4.5 seconds to hit the ground, which means the number in front of x is 4.5. So your answer there was just use your graph, a equals 4.5. Okay, so for question 13, part A, we're given the formula v is equal to u plus at. We're asked to write the formula in terms of t. Another way this question could be worded is they might say to make t the subject of the equation. At the moment, the formula is in terms of v, or you could take it as v is the subject of the equation. So basically it just means get the t on its own. Just isolate your t. So if I'm going from this line, just individually each time, just bring something to the other side. So if I v equals u plus at, I just subtract u from both sides. I get v minus u is equal to at. Then in order to get t on its own, I would just divide both sides by a, in which case I get t is equal to v minus u divided by a. And that's your final answer for that part. Okay, so for question 13, part B, we're told that g of x is equal to 9 minus 4x. And that g of t is equal to minus 3, we're asked to find the value of t. Well, first of all, you should realize that if g of x is equal to 9 minus 4x, you're able to find what g of t is. If g of x is 9 minus 4x, that means that g of t is, you just rewrite this, except everywhere there's an x, you put in a t. So I can say that g of t is equal to 9 minus 4t. So if I know that g of t is equal to 9 minus 4t, and g of t is equal to minus 3, I can just let them equal to each other. So I can say that 9 minus 4t is equal to minus 3. And this is the first step where I'm in familiar territory. This is just basic algebra. I've just got numbers and letters. So all I need to do is bring my numbers to one side, keep my letters on the other side, and solve for t. If I bring 9 to the other side, or in other words, I can just subtract 9 from both sides. I get minus 4t equals minus 3 minus 9. Which means I can say that minus 4t is equal to minus 12. To get t on its own, I'm just going to divide both sides by minus 4, in which case my final answer is t is equal to 3. Okay, so for question 14, I'm going to do part A and part B together. They've given me 3 different quadratic equations, they've asked me to solve them, and then they've asked me to identify which graph. They've given me 6 graphs, and 3 of them correspond to the quadratics I have. And I need to just match up my roots to the graphs. So the first one they've asked me to do is that g of x equals 0. G of x is x squared minus 3x minus 10 equals 0. Now there's loads of different ways of factorizing these, so if you're doing it differently to me, that's fine. I'm going to go with the method that the vast majority of you seem to be using. So if there's a minus at the end, that means my factors have to have a difference of minus 3. Basically, I know that that minus 5 multiplied by plus 2 will give me minus 10. And that minus 5 plus 2 gives me minus 3. So I'm going to rewrite this line. I can rewrite it. My x squared stays the same, my minus 10 stays the same, but the two terms in the middle are different. Rather than calling this minus 3x, I'm going to call it minus 5x plus 2x, because they're the figures I've identified here. Minus 5x plus 2x is still minus 3x. I'm just writing this equation in a different form. And now all I need to do is factorizing by grouping. What's common to the first two is x. If I take out x, I'm left with x minus 5. What's common to the second two is plus 2. If I take out plus 2, I'm left with x minus 5. Same thing in both brackets, happy days. X minus 5 goes in one of my brackets. The other bracket is whatever was outside it, which is x plus 2. So my factors in this case are x plus 2 times x minus 5. So in order to solve this, you let each factor equal to 0. You say that x plus 2 equals 0, which means x equals minus 2. You say that x minus 5 equals 0, which means that x is equal to plus 5. Now so that's for part A, that gets you your marks. But I want to do part B as well. Remember that the roots are the points where the curve crosses the x-axis. There was a plus in front of the x squared, which means that you know it's going to be a U-shape. It crosses the x-axis at minus 2, and it crosses the x-axis at plus 5. And I know it's a U-shape, so I know that it's going to look like that. Remember as well that the last number, whatever the last number in your quadratic was, that indicates where it crosses the y-axis or the y-intercept. So it's going to cross the x-axis at minus 2 and at 5, and the y-axis at minus 10. So if you flick to the next page, if you look at part B, clearly g of x is the first graph. The one in the top left-hand corner was g of x, because all of these things are true. Okay, so for the second one here, I need to solve h of x equals 0. H of x is 2x squared minus x minus 10 equals 0. I'm going to continue on by doing it by the factorizing by grouping method. The first thing you will do in a case like this is you'll take the number in front of x squared and you'll multiply it by the number at the end. So you're going to get 2 and you're going to multiply it by minus 10, and you're going to get 2 by minus 10 gives me minus 20. If it's a minus 20, that means one of your values will be a plus, one of your values will be a minus. You need to get two numbers that will multiply to give you 20, but have a difference add up to minus 1. Minus 5 multiplied by plus 4 will multiply to give you minus 20, and minus 5 plus 4 will give you minus 1x. So my minus 5 and my plus 4 accommodate both of my scenarios there, which means that you can rewrite your first line. The 2x squared stays the same, the minus 10 stays the same. The only thing that changes is instead of writing this as minus 1x, I'm going to write it as plus 4x minus 5x. Plus 4 minus 5, it still is the same value, I'm just writing it in a different way. When I go from here now, all I have to do is factorize out what's common from the first two and then what's common to the second two. Common to the first two terms here is 2x. If you factorize out 2x, you're left with x plus 2. Common to the second two is minus 5. If you take out minus 5, you're left with x plus 2. Again, same thing in both brackets, so I'm happy enough. That becomes an x plus 2, and then the other bracket is just whatever you have outside your brackets, which is 2x minus 5. So your factors are 2x minus 5 and x plus 2 equals 0. So if you factorize that, you get 2x minus 5 equals 0. If you solve it now, you get 2x minus 5 equals 0, which means 2x equals 5, which means x is 2.5. You get x plus 2 equals 0, which means x is minus 2. Now let's continue on. We're going to do part B as well. For part B, you should be able to imagine what your graph looks like. The roots are, I know it crosses the graph at minus 2 and it crosses it at 2.5. So the x-axis it crosses it at minus 2 and it crosses it at 2.5. The minus 10 tells me that the y-intercept is at minus 10. It's a plus in front of my x squared, so I know it's a U-shape. So my graph in this case, it's going to intersect minus 2, it's going to intersect minus 10, and it's going to intersect 2.5. So if you look on the next page now, it's clearly on the left-hand column, the one in the middle. Directly below where we assigned our g of x is our h of x. It's the second one on the left-hand side. Okay, the very last part of this exam now, I need to factorize f of x equals 0, but it asks me to leave it to 2 decimal places. to 2 decimal places is always a hint about your minus b formula. So if it says to solve this quadratic to 2 decimal places, I must be using my minus b formula. Where a is the number in front of x squared, it's 2. B is the number in front of x, it's minus 3. C is the number on its own, it's a minus 4. And I'm subbing into x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. You can get that straight from your log tables. So that's the way I would set up my question. I'd write a, b, and c, I'd write my formula, and then it's foolproof. Then you just sub in. Instead of a b, I'd put in minus 3. Instead of an a, I'd put in 2. Instead of a c, I'd put in a minus 4. When you've plugged it all in, then what I would do now is simplify what's in the square root. If you simplify just the numbers in your square root, it works out as 41. So it's actually just x is equal to 3 plus or minus root 41 over 4. Then you just take it in one scenario, you take the plus. In the other scenario, you take the minus. If you put 3 plus root 41 over 4 into your calculator, to 2 decimal places, it's 2.35. If you put the minus into your calculator, to 2 decimal places, it's minus 0.85. So your two roots in that case are this value and that value. That's the marks going for part A. Well, now let's consider part B. For part B, now you've identified your roots, you should be able to draw yourself a nice sketch. I know that it intersects the x-axis at minus 0.85. It intersects the y-axis at 2.35. And it intersects the y-axis at minus 4. The y-axis at minus 4, the x-axis at minus 0.85 and plus 2.35. Again, there's a plus in front of my x squared, so it's a U shape. So my graph, if I draw it, it's going to look something like that. It's going to intersect at minus 0.85, at minus 4, and at 2.35. So now you can go to the next page and you can figure out which graph it is. Clearly the only one that satisfies that for f of x is on the left-hand side, the one at the very bottom. The one directly below your h of x, you'll plug into that one that it's f of x. So that's the last part of the test. Make sure you've written out all of your solutions, and when you finish watching this video, I want you to write a list of the things that you did wrong. Because the mistakes you made now and the mistakes you're likely to make in June are the same. So I want you to hone in on the things you did wrong, the things that you're disappointed with, and you make sure that when you do your exam in June that you're much better at those ones.